Today's presentation will be focusing on how to source free topography data in Australia and also how to implement that data efficiently within a TUFLOW model. I've split the 10-minute presentation up into 3 separate parts. To start with, I'll show you where to obtain the data. I'll then show you how to implement it and also step through some quality control examples. Step 1, where do you source the data from? The web link is shown in the top right. Obtain the information is really simple. Just go to your area of interest and select the location where you'd like to extract DM tiles. A list will populate for that area, and you just have to select of that available list which ones you would like. You can see as I hover over each data set there, you see a red icon in the map window on the left. Click download. After making this request, you'll receive an email with a link to those files. Here I've downloaded the dataset. If I go into it, you'll find the zip file actually contains a series of other zips. And those subsequent zip files, each one of those contain a unique DM tile. I'm just copying those to a data folder in my project. And I'll unzip them all together in a batch by selecting them all in Windows Explorer, right-clicking to 7-zip and clicking Extract. And I'll save these to the TUFLOW model grid folder. These will be the inputs that are read into the TUFLOW model. This is quite a small example, only 20 DM tiles. Bigger model areas might require hundreds, if not thousands of tiles. As you can imagine, with a dataset that includes thousands of tiles, listing each of these DMs in your geometry control file can be quite problematic. So I'll show you an automated way how you can capture all of that information without missing anything. Something to note here is you'll see the name there for the DEM exactly mirrors the folder name within which it resides. That's important information to have when we're trying to reference these files in the geometry control file. Just a quick note, in the next 2 slides I'll show you how to obtain a list of all those files and add them to a TUFLOW model. But if you'd prefer to work through steps following a bullet point list, please go to the wiki, go down to the tips and tricks section, for DOS commands, and the last item titled Write a list of files contained within a folder includes all the steps you need to follow. Yeah, very useful resource. Look, in short, the steps are this. You'll have to open up command prompt. In there, you'll change the directory to the location where your DM folders resides. And once you're there, you'll just have to write a list of those files out, just in a text form. Okay, I've done that there. I can now open up that new file, and I have a list of all the folders. I'll now use that information to help me place commands within my geometry control file. When I'm using DM tiles like this, I like to actually consolidate all of my DM commands in a TRD file. That way I'm not overly complicating my geometry control file. It just keeps everything neat. So I'll show you how I'll do this. I create a new text file in my model directory. I give it a name and append an extension of TRD. I can open that up in Notepad++ and then use column mode to edit it. So before that those folder references, I can prefix it with the relevant command and the necessary path updates. So that would be read grid z points equals, and then space grid backslash. Then what I need to do is copy all of those folder names and append to the end of that a backslash, those folder names, and then .asc. And by doing that, I'll have correctly referenced every single DM tile that I just downloaded. I can right-click one of these files just to check that it opens. If it does, then the syntax I've used is correct. After making that TRD file, I just have to update create a reference to it in the geometry control file. You'll see prior to that, I've actually got the set z points 100 command listed. We'll get back to that later when we're talking about the quality control, but that's an important input when it comes to trying to identify data gaps between these various DM tiles. So I recommend including a command like that. Just set the elevation to a value which is significantly higher than what you'd expect in any of your DM tiles. Okay, after having made that update, run your model and import your DMZ check file into QGIS. There we go, my model's running. It's running the grid check and the DM check file right now. I can go to the check folder and I'll just look for the DM underscore FLT, or DM underscore Z FLT file and drag that into QGIS, and there we have it. I can now check that all those tiles have been imported correct or interpreted correctly by TUFLOW. Yeah, it looks quite good. What happens, however, if you find that there are gaps between the various tiles? I've seen this with some data sets. Firstly, let's reflect on how you would find those data gaps. You recall that I listed the set z point command equals 100. By using that command, all I need to do in my dm underscore z file is search for that value. If I find that value, because it's all of twice, if not more, higher than the surrounding elevations or what I'd expect the elevation to be, it will automatically tell me where data is missing. And there we go. You can see a small slither just between two of the tiles. Now to correct for that data gap, we can easily just use the read GIS Z shape command. We'll define a Z shape polygon or region. And by default, when we input this dataset into TUFLOW, TUFLOW will sample the elevations around the perimeter of the polygon and then tin through the polygon based on those sampled elevations. You don't actually need to put any inputs with this option. It's a default state that it'll sample in that manner and also tin in that manner. We'll update the geometry control file to include reference to that file and then rerun the model. Let's look at what happened after we ran that model. And much like we did before, we can bring in the DMZ check file. Now you can see where there was the data gap. There isn't anymore. We've tinned across it. Another very useful check file is the shape object check file. The R type of the three options there will show you where TUFLOW tinned across that area. Yeah, look, that concludes the presentation. I hope you found that useful. That online data set is really easy to access and quite valuable. Um, Updating your models to reference thousands of DM files is really pretty simple. And then also, as long as you use a logical approach, checking and correcting any potential data errors is also pretty simple.